In this, I'm going to discuss about the two statement. First is a cyclic integral of dw is equals to cyclic integral of dq for cyclic process, and this is for non-cyclic process. Heat supplied to the system is equals to work done by the system on surrounding plus change in internal energy delta E. These two are the that is a mathematical expression for the first law of thermodynamics. We say actually thermodynamics law has no mathematical proof. It is based on experimental evidences. Experimental evidences and it is law of nature. It is a law of nature. Law of nature. That is okay. First law of thermodynamics. It is for whenever the thermodynamic system undergoes a thermodynamic cycle, the net heat supplied to the system is equals to work done. For any cyclic process, the heat supplied is equals to work done. Or you can write for any cyclic process, for any cyclic process, the heat transfer is equals to work done. Heat transfer is equals to work done for any cyclic process. Heat transfer is equals to work done. These are the machine, the imaginary machine, a machine which violates the first law of thermodynamics is called perpetual motion machine of first kind. Okay. That is, in short, it is called as a PMM1. Okay. See, this is a machine. That is a machine which gives that is a Q is equals to 0, and it gives a W amount of work. It means that nothing is consuming, it gives W amount of work. Means without consuming any source of heat, that it gives W amount of work, and it is called as a total imaginary concept. Okay. If we want to produce certain work, should be the energy expenditure is required. Okay, such machine is called as a PMM first, and it is imaginary one. It does not exist in nature. This is all about the first law of thermodynamics. Okay. Next is a application. Application. First for closed, that is a for constant pressure. Constant pressure. You say first you take constant volume instead of this constant volume process. You see this PV diagram, pressure versus volume, and see this TS diagram, temperature versus entropy. Then this represents that is a constant volume process. Say this is a point 1, say this is point 1 and this is point 2. The volume is to be remains constant, so it is called as a constant volume. V1 is equals to V2, and at this point the corresponding coordinate, this is called as P1 and this is called as a P2. Okay, and this coordinates you have to draw this constant volume line here. You have to draw the constant volume line, and that line you have to draw in this way. And on this line, if you take this one, this is a point 1, 1, and this is a point 2, and this process 1 to 2 is called as a constant volume process on the TS diagram. This is at this point 1, the entropy is just 1. At this point 2, the entropy is just 2. Entropy just 2. And the corresponding this temperature is T1 and this temperature is T2. Okay. If you look at this, area under the PV diagram represents the work done, and area under this diagram represents the heat transfer. It means that during this area under this curve, under this line, the curve is called as a heat transfer. That is, I show here, that is by letter Q. It is area under this curve represent the heat transfer. Okay. Then first in that we are going to write here, the first is PVT relation. Pressure PV by T is equals to constant. Okay, but in case we can write also for this process 1 to 2, this is a heating process, constant volume heating process. In that we can write here P1 V1 by T1 is equals to P2 V2 by T2. Okay, as the where volume is constant, V1 is equals to V2, V1 is equals to V2, then this equation become P1 by T1 is equals to P2 by T2. Therefore, this can be written as T2 by T1 is equals to here P2 by P1. This relation you should know, that this is called as a PVT relation. PVT relation. That is. Next is we calculate the work done. That is work done. Work done during constant volume process. That is, what is this work done? See, we know that the definition of work done is equals to, it is the integration of 1 to 2 P into dV, pressure into change in volume. It is a thermodynamical work, and that can be written as this equals to P is a constant, and we can write here 1 to 2, that is a V dV. Again this become P into this is a V integration 1 to 2. Therefore, W is equals to P into this is a V2 minus V1, and since here V1 is equals to V2, put this value here, the work done is equals to 0. Note down, during this constant volume process, work done should be the 0. The work done should be the 0. Okay, this is a mathematical. And you can also conclude here that W is equals to 0 because there is no area under this PV diagram. It means the work done is 0. Okay. Similarly, we can calculate the next is a heat transfer. Heat transfer, TRANS, transfer, that is Q. As per definition of first law of thermodynamics, Q is equals to W plus delta E. Q is equals to W. Since W is equals to 0, you can write here 0, since for this process W I already proved that Q is equals to delta E. That is, the heat transfer is equals to change in internal energy. This you do not know. Again, you can write this is a Q is equals to, this is a CV into T2 minus T1. Okay, this is the heat transfer during this process. Okay, thank you.